record this part alone. Then we can drop it on YouTube channel later. I move to data link layer. What is going to happen at data link layer? Data link layer is called layer 2 under OSI model. And this is when we call our data frame. So why is it that we call data frame, our data frame at layer 2? I'm going to explain to you. Data link layer is responsible for communication between end devices network interface card. It allows upper layer protocols to access the physical layer media and encapsulates layer 3 packets. You see now I told you about packets at layer 3 into layer 2 frames. So when the packet gets to layer 2, the packet or the data is called frame. So it's a layer 2 issue. So sometimes I can be telling you, okay, let me put it this way now. If I am trying to mentor you on how to build a network, or you want to go and do a contract somewhere, I'll ask you questions. How far have you gone with the job, or how are you going to execute? What is your plan for your layer 1? What am I referring to? What kind of cables do you want to use? How are you going to run your cable? Are you using CDT step here? Are you using copper? Are you using wireless? When I ask you, okay, what about layer 2? What have you done about your layer 2? I'm asking the kind of switches you are going to put in place. Are they managed switches? Are they unmanaged switches? Then if I ask for layer 3, what's your plan on layer 3? I'm asking for your router, because router operates at layer 3. If I ask for a layer 4 issue, I'm talking about your firewall and some other stuff. Then I cannot ask you, when you are done with all of this, do you need have a need for any server on your network? All of this is falls back to OSI model. When we are building network, when we are troubleshooting network, when we are analyzing packet. So now look at what they are saying about data link layer. They said it enables what? The upper layer to access the physical media layer. Why? Because it's the one residing between the layers from above and the physical layer. Because after your physical layer, you have data link layer. Now look at another thing they said. They said it performs error detection and reject corrupt frame. What is error detection? If there is an issue, it's like, let me put it this way, it's like you downloaded something from the internet and you are now trying to open it and they tell you that it's not fully downloaded, so it cannot open. So in the process of transmitting from source to destination, sometimes there could be error. If there is an error, data link layer can detect the error and reject corrupt frame. And if you reject corrupt frame, what's going to happen? Another layer can take care of retransmission, and we are going to get to that place later. But there's something I need to point to you, which we need to really emphasize at this data link layer. Your switch is a layer 2 device. We've talked about network devices before. Your switch is a layer 2 device. Why is a switch called layer 2 device? Because the switch uses what we call MAC address. What is MAC address? MAC address is a layer 2 address. How do you find MAC address? Every computer has MAC address. Like this, my computer that I'm using to teach you guys right now, it has a MAC address. So your computer you are using to listen to me or watch me, listen to me, has a MAC address. As long as your computer has network card, that computer has a MAC address, because the MAC address is inbuilt. It's inbuilt into the network card. It is embedded in the network card. So it therefore means if I remove my network card right now and put another network card, it simply means the MAC address of my computer has changed. Or put it this way, I have wired network card. That is where I can plug network cable. And I also have a wireless network card. So it therefore means on this my computer right now, I have two different types of MAC addresses. One for wired, one for wireless. So MAC address on my computer is called a layer 2 address. So before the end of this class, I'm going to show you how you can find the MAC address on your computer. So that address is called a layer 2 address. That address is also called a physical address. It is a layer 2 address. It is a physical address. It is an address that pins you down to a location. If I want to look, if I want to trace somebody's packet right now, or I want to know where you are on my network, once I know your IP address, I see what you are doing, I see that you are doing something bad. With your MAC address, I can pin you down to your office. From switch to switch to switch to switch to switch, and know where you are. It's like your local IP address. I mean local address. So when you talk about MAC address, your network card, the network card on your computer has MAC address, and it is embedded. And you cannot have two computers in the whole world with the same MAC address. No way. Every computer has a unique MAC address. So why are we talking about this? So anytime you talk about MAC address is a layer 2 issue. Why? Because the switch that belongs to layer 2 uses the MAC address to make decision. What do I mean by that? If I connect two computers together and those two computers want to send data to themselves, the switch does not have any business with their IP addresses for it to deliver the message from source to destination. It will just check the source MAC address, destination MAC address, and know that this message is going to somebody that is on so port on myself, and then push it to that person. And I'm going to demonstrate this to you guys. So whenever you're talking about layer 2, let your mind go to MAC address. Let your mind go to switch. A switch is a layer 2 device. Why? Because it uses MAC address to make decision. Switch does not have any business with layer 3. Just a minute, please. Switch does not have any business with layer 3. Switch does not have any business with IP address. The person that has business with layer 3 or has business with IP address is your router. So we talk about switch, we talk about MAC address. We talk about layer 2, we talk about MAC address. We talk about layer 2, we talk about your switch. We talk about switch, we talk about frame. All of this is revolves around. And one of the reasons why you need to know some of this is when you are troubleshooting, you need to be able to say, this is not a layer 1 problem. All my cables are intact. They are working well. Let me escalate to layer 2. So what are the things you are going to be checking for at layer 2? If the device is connected to your switch, does the switch know the MAC address of that your device? Because if it does not know the MAC address of or is it learning the MAC address of that your device, is the switch still functioning properly the way it's supposed to function? These are some of the reasons why you need to know about OSI model, and you need to know about the flow of packet, because you are going to make use of it's going to make you a better engineer in your field. Okay, so when we talk about layer 2, we talk about MAC address. MAC address is embedded in the network card of the computer and is also referred to as a physical address. These are some of the things you need to take note of when we talk about data link layer. We still have other things to talk about here. Let's just take it slow and steady. Okay. Okay, sorry. So now, another thing I want you to understand about data link layer. You can break down data link layer into 2 sublayers. One is called local link control, and the other one is called media access control. So the data link layer can be broken down into 2 sublayers. One is called local link control. The other one is called, I want to annotate, let me show you guys. So you can see here, this is one here, LLC sublayer, and then we have MAC sublayer. LLC sublayer, MAC sublayer. So this data link layer we are talking about, we can break it into 2 again. It's a layer by itself, but inside of it, it now has 2 layers. So what is the job of these layers? Look at it here. The LLC sublayers communicate between the networking software at the upper layers and the devices at the lower layers. So the LLC is what the data link layer is using to talk to the upper layers. And for it to now connect to the lower layers, is still a part of the LLC, which actually I want to take the mark sublayers now. It uses the LLC to talk to the upper layers and uses the mark sublayers to talk to the lower layers. So look at the way they put it here. The mark sublayer is responsible for data encapsulation and media access control. What is the meaning of that? If my data link here want to talk to physical layer, it uses the mark sublayer. So when we say it's responsible for data encapsulation, meaning what? I know that my data is going to turn from frame to zeros and ones at physical layer. The guy that is going to start getting that job done as is leaving the data link layer towards the physical layer, he is my mark sublayer. So your take home here is, when you mention data link layer, just note that inside that layer, you still have two sub layer, and the two sub layers are LLC sublayer and mark sublayer. One is used to talk to the upper layers. The other one is used to talk to the lower layers. That is just the best way to understand this one. So when you capture a frame now, well, is it possible to capture a frame? Oh yeah, you're going to see when we come to when we use our Wiresharks to capture frame. When you capture a frame, how does it look? What does it look like? How does a frame look from our Wiresharks? Or let's say somebody is trying to hack into your network and they've been able to capture your data. They can do this analysis that we are going to be doing too. So when the frame is captured, what are you going to see? Data is encapsulated by the data link with a header and a trailer to form a frame. So a data link frame has three parts. So the frame has three parts: the header, the data, and the trailer. What is the job of the header? What is the job of the trailer? What is the job of the data? The data itself is the real message you are sending. Now let me put it to you this way. If I want to send message to you right now, I write the message. I get a sheet of paper, I write the message. The sheet of paper is not the message. Even the ink that puts my message on the piece of paper is not the message. But I'm going to get a sheet of paper, write the message, fold that paper, put it in an envelope. The envelope is not the message, but the envelope is needed to help to convey the message to the destination. Then buy stamp and put on the envelope and write from on one side and to on the other side. All of these things I'm doing, that they are not the message. The real message is on the paper. The paper is not the message. The ink that is on top of the paper is not the message. So the same thing when we are sending data from source to destination, so many things are needed to help us to help that message to get to destination. So when your data starts from application layer, I'm still going to go to application layer, and it's data from application, presentation, and the session layer. We call it data. By the time it gets to transport layer, something is added, and that thing is called a header. It's like an envelope. So we put the data inside an envelope and label that envelope for transport layer. So what is in that header? I'm going to talk about that when we get to transport layer. But you now come down to network layer. Another header is added. And that one too, the previous envelope will be put in another envelope with a message on top of it. When it now gets to layer 2, which is data link layer, another header is added. And guess what? What is in our header at layer 2? Look at the picture here. What is in our header? What is in our header? We have the frame stats, we have the addressing, we have the type, we have the control. What is the meaning of all of these things? The most important thing we need in this our header is the addressing. What is in that addressing? The source MAC address. It simply means where the message, the layer 2 address of the sender is going to be in that header. And the destination MAC address, which is where the message is going to, is going to be in that part of the header. So the address field inside the header is the one that carries the source MAC address and the destination MAC address. So the data is there, nothing is happening to the data. It is the way we have sent it. But something is added, it's called the header. Inside the header, we have so many things there. And also a trailer is added. Inside the trailer, we have some things there. I've talked about error detection briefly. So the most important one we need here, what we need to understand here is the address field. So the address field is in the header. And that is where I'm going to have the source MAC address and then the destination MAC address. So when that message gets to destination and is going through the process of the encapsulation, the destination is able to open. Sorry, I just noticed a network problem from my own end. I had to switch network. Sorry about that, guys. So let's just hope the network today will be friendly. Let's just continue from where we stop. So if you have questions, please don't worry. I'm going to answer questions. I'm going to answer questions. Don't worry about that. Any question I'm going to answer. So you notice that while I was teaching this particular class, I didn't have this writing pad that I'm using to circle tin and all of that. This is the address field I was talking about in that place. This is the address field, this address field here. So anytime you talk about frame header, because you're going to always have either frame header, segment header, or what's the other one called? Packet header. Frame head, segment header, packet header, or frame header. So we're breaking down frame now. So when you capture a frame in real world now, I'm talking of real world because it is possible to capture a frame with Wiresharks, guys. And these are some of the things that the cybersecurity guys will do. From there, what we are looking at is we want to check this header. And what are we going to see in the header? The source MAC address. Who sent this message? Destination MAC address. Where is the message going to? These are layer 2 addresses. Source MAC address, destination MAC address. This is the real data, guys. Just like I was giving that analogy at the beginning, you're going to have the data in an envelope. A message will be added from some source to destination at layer 4, at layer 3, at layer 2. Different things will be added as the message is moving on until the message gets to destination. Of course, once it gets to physical layer, you know that it becomes zeros and ones. So since we're dealing with data link layer in today's class, that is why we are bringing. Now, what about other feeds? We don't really need all those other feeds now. You can read some of the summary, what they are telling us about other feed. I'm not going to go into the details of those ones. But the most important feed to us here is this addressing feed and error detection feed. So any question you have, just keep on writing them down. I will proceed and then we'll answer the question later. Let's just hope the network will be friendly. From so person, and you are going to so person. This is the person's layer 2 address, and this is the person's layer 2, layer source layer 2 address and destination layer 2 address. This is the person's layer 2 MAC address, where he's coming from, and he's going to so person. So all of this happens at layer 2. So the things that are added at layer 2 is not just my source MAC address, it's not just my destination MAC address. Other things are added in the header, but the most important one we are concerned about is the source MAC address and destination MAC address. So everything needed for the information to get to destination, the data to get to destination, safe and sound, is being added as we move from layers to layer. So we are still going to be exploring this frame. Okay, so these are some of the things that we have talked about before. Data link layer has two sublayers, LLC and MAC, and there's a way they used to refer to LLC. 802.2. The way they refer to MAC and the physical layer, 802.3. And the old technology at layer 1 and 2 is called Ethernet. I'm going to pause there and say some things. When you talk about Ethernet, do not confuse Ethernet with Internet. They are two different things. I repeat, don't confuse Ethernet with Internet. They are two different things. Ethernet is a LAN technology. Ethernet is a LAN technology. What do I mean by that? Now, it's like in those days, there are different types of technology you can use to build your local area network. They had Ethernet, or they have Ethernet. They have token ring. They have ATM. There are other ways that people build local area network. It simply means this is our own way of building our own network. So everybody back there, they have there are different ways of building local area network. But then Ethernet became the dominant LAN technology. It simply means it's a LAN technology or a way of building LAN that dominated, that took over. And one of the reasons why it was able to take over is because the technology is flexible. It was able to move from a lower bandwidth to higher bandwidth, from a lower speed to higher speed. So right now, all the LANs we have in the world, they are built on Ethernet technology. And when I say they are built on Ethernet technology, that's why if you go and buy a network cable right now, on top of the Ethernet cable, you will see they will write Ethernet. If you buy a switch, that's why right now you see that they will write Ethernet on the switch. Why are they writing on? They just telling you that this is the technology we are using, and these devices, the cable, the network devices, the router, they are built to follow or to operate according to Ethernet technology. So when we talk about Ethernet, it's different from Internet. Now look at what they are saying here. Ethernet operates in the data link layer and the physical layer. What do they mean by that? Whenever we are talking about LAN technology, when we come to CCNA 3, we are going to be talking about wide area network technology. Whenever we are talking about either WAN technology or LAN technology, we say this technology operates at layer 1 and 2. What does that mean? The only way for you to differentiate between a particular LAN technology and another LAN technology, or a particular WAN technology or another WAN technology, is only at layer 1 and 2. By the time the data cross border to layer 3, you don't know the difference again. We don't know whether we are using Ethernet, whether we are using token ring, whether we are using ATM. That is why they said this technology operates at layer 1 and 2. And I didn't get the information in CCNA or CCNB. I got this in CCIE, one of my CCIE materials. Because over the years I used to teach, they say, okay, Ethernet operates at layer 1 and 2, one technology layer 1 and 2. It was from a book that I now discovered that the reason why they say they operate at layer 1 and 2 is because these are the layers where you can separate the technology. You'll be able to tell, this is so technology. This is so technology. But the moment they cross to upper layers, or network layers and above, you can't tell the difference again. So the reason why we are concerned about Ethernet is because that is what our LAN is built on. That is what our local area network is built on. So Ethernet is a LAN technology. Ethernet, not Internet, they are different things. It's a LAN technology. And when I start demonstrating, I'm going to tell you this is why they call this one Ethernet, or this particular technology is what they refer to as Ethernet. The access method is different from another technology. When I say the access method is different, let me give you an example. For token ring uses the technology like a baton. It's like when you are running a race. Until you have the baton, you cannot take off. So in a token ring network, there is a baton that moves from computer to computer until it gets to you before you can send data. That is how that technology works. But if it is Ethernet, anybody can send data. When you have data to send, you just push your data and there will be no problem as long as the network is not running on half to place. So that is just what I'm trying to talk about on Ethernet technology. So they said something here. It is a family of networking technologies defined in IEEE 802.2 and 802.3 standard. Why did they call Ethernet a family of networking technology? Because right now, we have gone beyond Ethernet. We have variations of Ethernet. What do I mean by that? Ethernet being the starting point only runs at 10 Mbps. I believe you guys should know what I mean by 10 Mbps, 10 megabit per second. But right now, networkers have gone beyond Ethernet. We are now on gigabit Ethernet. We used to be on fast Ethernet. So if you buy a switch right now, you see that they probably wrote 100 Mbps on that switch. That tells you that that switch is running on fast Ethernet technology. For instance, I built a network for an organization last year. The whole thing, everything we put on the network is gigabits. That was built on gigabit Ethernet. That's another speed. That is 1 billion of bits in a second. So when they tell you that Ethernet is a family of networking technologies, it simply means it has variations of this technology. All of them are based on Ethernet, but they have different speed. 10 Mbps, 100 Mbps, 1 gig. Now we have some people even say there is 80 gigabit per second right now. That is the crazy speed that you can build on local area network. So Ethernet is a LAN technology. And whenever we talk about Ethernet, it operates at layer 1 and layer 2. And I've told you why they said it operates at layer 1 and layer 2. So back to our frame. So when we talk about frame, we are simply talking about Ethernet frame because the technology we are using is Ethernet. So if our data becomes frame, it's running on Ethernet technology. So when you capture your frame or your Ethernet frame, this is exactly what you are going to see. And I've talked about this one before. Exactly what you are going to see. Now, the most important thing to us in this frame right now, the most important thing to us here is this destination MAC address, source MAC address. All other information here, don't bother about those ones. They are things that you can learn in the future when you come to some things like maybe higher level of this training. So there are so many things to talk about when you talk about layer 2, but I will just emphasize on the most important thing at layer 2 and leave it there. Now I need to talk about this. The minimum Ethernet frame size is 64 bytes and the maximum is 18 bytes. What does that mean? If you are talking about collision, we're not going to be talking about collision in this class because we don't have collision again, but you need to know about that. In those days, they used to have collision. You need to know about if a frame is involved in collision, if it's messed up, if it is a giant frame, and what kind of configuration you need to do to support a frame that is bigger than 18 bytes. So many things to talk about, but I will just limit it to what is important to us here. Source MAC address, destination MAC address. I hope you guys are hearing me. Please, if you are hearing this recording, please give me thumbs up because I'm seeing some people saying they can't hear or I forgot to open mic. So it's from your own hand, please, if you can't hear me. Thank you, guys. Thank you. And don't forget, I'm going to come and answer questions. Don't worry about that. But I have some things that I demonstrated in this video that I think it will interest you guys. Thank you. So, still talking about Ethernet. So, when we are saying layer 2, we cannot separate MAC address from layer 2. We cannot separate switch from layer 2. And we cannot even separate the so-called LAN technology, which is Ethernet, from layer 2. So, MAC address in general. What is a MAC address? It's a 48-bit binary value. So, when I talk about MAC address now, it's always in binary. It's 48-bit binary, but it is expressed in hexadecimal. Let me just show you guys. Let's do this. I'm going to go to my system. I think I need to reshare this one. Can you guys see my my command line. This is called a command prompt. Can we all?
Yes,
we can see, right? We can see, right?
Yes, we can see it. We can see.
Okay. Sorry, let me.
Yes, we can.
All right. I need to reshare it. So this is the command prompt on my computer. So for you to get to this environment, just type CMD from your search or command prompt, or just hit command and hit enter. So if I want to check the MAC address of my computer right now, this my computer has a MAC address. I will say ipconfig /hall. ipconfig /hall. By the time I hit enter, it's going to display so many things. But let me now go from up and start analyzing for you guys. This is where I issue the command ipconfig /all. So it's giving you some information. Okay. So what are the information this guy is giving us now? I have Ethernet adapter. Ethernet. Now look at the state, the media state. Media disconnected because I'm not connected to wire. I'm not using wire. But let's come down here. And this is another card. This is another network card. I have some funny things on this laptop here. He's saying this one too, media is disconnected because I'm using VirtualBox. Where is the one that is connected now? I'm using Wi-Fi because I'm using hotspot to teach you guys. Look at my wireless LAN adapter, the Wi-Fi here. Now so many informations are given here, but the one I need right now is this one called physical address. Remember I told you that layer 2 address is also called physical address. So the physical address of my computer or the MAC address of my computer is OC 8B FD B6 61A1. This is represented in hexadecimal. We can convert this to binary. I'm going to send you guys video before we do IP addressing on how to convert binary to decimal, hexadecimal, and all of that. So this is my physical address. Here's my MAC address. Let's say, for instance, now I don't want you to browse on my on my network wirelessly. All I need to do is to get this your MAC address, block you, add it to my access point, and block this MAC address. So when you want to try to browse, my router sees you, my wireless router sees this MAC address, and that you have been configured not to be able to browse now, so you won't be able to go. Now, if you look at this physical address, there are how many? Just a minute, please. There are how many hexadecimal digits here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each of these hexadecimal, do I call it digits now, value is 4 bits. 4 bits. So by the time you multiply 4 times 12, that gives me 48 bits. So it therefore means my MAC address, if I'm going to convert this to binary, it will be 48 bits. This same MAC address, it was my switch is going to use to make decision. So I would like to add 1 or 2 things there, guys. Somebody said this thing is tiny. So let me just show you on my own hand here. If I go to my computer and type CMD from search, I hit enter. This is my command line. CMD. CMD, another way to represent represent CMD is to type command. You can just search for command from your search button, and then you hit enter. It will bring you to this environment. This is what we call a command prompt. Now, in this environment, we do a lot of things. For instance, now if I want to see if there's network, the network is good or is messing up, I can say, okay, ping www. I don't know if I've been here with you guys before, google.com. Then from here, I can do some analysis from this output. One of the things I can do is I can check the average speed. That is what we call jitter, the average speed to go to and fro. So I will check the jitter, I'll check the latency. Basically, it's talking about both the jitter and the latency. So from here, I can say, oh, my network is actually bad. My network is slow, and so on and so forth. We're still going to come to things like this. But another thing we'd also do from command line is we can check the IP address of the computer. Don't forget, computers must always use IP address, and this is a layer 3 issue. So if I just put ipconfig and hit enter, you're going to see that it's going to show me IP address on my wireless card, because I have one card here that is used on VirtualBox. If you know about VirtualBox, which is used to do virtualization, but that's not the one I'm particular about. I am particular about this wireless LAN adapter. You can see this is my Wi-Fi card. I don't have LAN card on this laptop. So you can see that it shows me an IP address, both for IPv6, IPv4, subnet mask, and default gateway. All of this we are going to learn how to analyze as we proceed. But in the context of what we are discussing right now, I want to see the MAC address on my laptop. Since I have only one wireless card, that means there's going to be only one MAC address. So I'm going to say ipconfig spacebar /all. ipconfig spacebar /all. By the time I hit enter, you see I have more information that I got earlier. I got more information on that my wireless card. And guess what? This is what I'm looking for here. Physical address. That's another way to refer to your MAC address. Physical address is the same thing as MAC address. It's the same thing as layer 2 address. So now this is the MAC address of this my wireless card now, and it is represented in hexadecimal. For those of you that don't understand what we mean by hexadecimal, we're going to we have a class dedicated to that. We're going to learn how to convert binary to decimal, binary to hexadecimal, and vice versa. So all of these hexadecimal things I'm mentioning right now, we're going to come to that. What we are simply telling you, this address is not represented in decimal. At least you know decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on and so forth. That is decimal. And when you talk about binary, it's in zeros and ones. But this address that we are looking at is not represented in decimal. It's not represented in binary. It's represented in hexadecimal. But you know what? Computer does not see this in decimal or hexadecimal. Computer sees this thing in binary. And that is why we're going to have a class dedicated to that conversion alone. So like this is my physical address right now. We need to find out how is the computer seeing this address. Since we say computer does not speak decimal or hexadecimal. But the only reason why MAC address is represented in hexadecimal is because it is easier to shorten numbers. The same thing with IP version 6. When we come to IP version 6, we can easily shorten numbers that are long. And you're going to see as we proceed into this class, MAC address is 48 bits. What do we mean by that? If you count these hexadecimal digits now, they are 12, 1, C, 8, 3, 4, 8E, 4, 9, 8A, EE. Each of the digits you are looking at in this place is 4 bits if you convert them to binary. Combination of zeros and one in 4 places. So by the time you multiply them, what I mean by them is the total number here is 12. Your MAC address is 12 hexadecimal digits, and each digit is 4 bits. By the time you multiply 4 by 12, that means your MAC address is 48 bits. So what's the big deal about this? It's a layer 2 address. You cannot travel without being tagged with this address. Source MAC address, destination MAC address. Wherever you are going in the world, the computer you are going to talk to has a MAC address. You, the sender, you have a MAC address. And this is a layer 2 address. If it is missing in that message is going nowhere because it's part of the protocols. It's part of the things that were explained in OSI model when they were explaining to people the flow of data. Now at layer 2, source MAC address will be added to the message. Destination MAC address will also be added to the message. And that is what we see in our frame header majorly. There are other information there, but the main frame header, that is what you have. This is one of the information you have in the frame header. The source MAC address, the destination MAC address, apart from all the other stuffs you have. So the frame header basically carries source and destination MAC address. And somebody asked me a question in the class before that the PDU, she's confused about this, the PDU, I think is a class rep, protocol data unit. Protocol data unit basically is what the data becomes at different layers. Like in layer 2, our data becomes frame. Why are we calling it frame? Because source and destination MAC address are added. That's why we call our data frame. But we're telling you where that MAC address is located. It is burnt in the in the network card of the computer. Burnt in. If I remove this wireless card right now, I'm going to get another wireless card and put on my computer. The wireless MAC address has changed. So you need to be aware of that. So we're going to come to hexadecimal, the calculation. So if some things are still looking spiritual here or still looking confusing here, don't worry, we're going to break those things down when we come to calculation. So you will see this MAC address in binary or in decimal. And one of the usage of this is you can decide to block people from connecting to your network. You get their MAC addresses and you put it in your access point and you block them. Even if they have the password to your wireless network, because you have blocked them, they cannot browse on your network. Or you reverse the case. You only get the MAC addresses of the people you want to allow to browse through your wireless access point. Just put it in your access point. Tell your access point, when you see these people with these MAC addresses, they are the only one that can browse. So even if people should pass password around between themselves, oh, you have using the new password, as long as they are not permitted by MAC address through that router, through the access point, they cannot go out. That's one of the way we use the MAC address, apart from the OSI model. OSI model, we do what they need to do. Or packets or frame or your data, they will do what they need to do. We're just trying to explain things going on behind the scene. So I believe that is clear. So let's quickly, because somebody said it's tiny, that's why I decided to just launch it. So let's move on. Thank you, guys.
So the moment I connect my computer to the switch like this, it needs to know about this MAC address before you can make decision. When I say make decision, if somebody said if computer A sends to computer B, the switch has something called a MAC address table. We have to get there today. And with that MAC address table, it's going to make a decision where to send the message to. So this is what I'm trying to talk about. So your MAC address is embedded in your network card. And it depends on the card you are using before you can say this is the MAC address I'm referring to. Right now that I'm using wireless, I'm talking about this particular MAC address. If I plug cable to my network or to my right now, the other MAC address too will show up for my physical port. So that is just that on the MAC address. Okay. So back to my PowerPoint. Can we still see the PowerPoint? So now we can see the PowerPoint, right?
Yes.
Yes. So there's something you need to know about MAC address. MAC address can be divided into two portions. The first part is called the OUI, Organizational Unique Identifier. The second part is called vendor assign. Vendor assign. So what is the difference between the two? Let's say right now, HP have their own network cards. Cisco probably have network cards. So if Cisco produce 1 million cards right now, a certain portion of the MAC addresses of all the computers will be the same. That is the one that represents that this particular network card though, or this MAC address is from Cisco. If Dell should produce network card, if they should produce 1 million card, a certain part of the MAC addresses of all the cards will be the same. So that is the part that is representing the organization. And the other part, which varies, which is different, is one that will really tell about the particular computer. So if you look at my computer right now, certain part of the MAC address of my computer will be the same with some other computer. It simply means the manufacturer of the network card here. And those computers, the manufacturers are the same. So sometimes when you see some computers, they have the first, I think that is 1, 2, 3, 4, 5, 6. The first 6 hexadecimal or the first 6 hexadecimal digits or value are the same. The others are different. Once they are the same on all the computers, you know that all those network cards are from the same vendor. So that is another thing you need to take notes there. So frame processing, how does the switch process a frame? Meaning what? How does the switch even get to know that you are on the computer? I mean that you're on itself before it will send message. I'm going to demonstrate this to you guys. So let me just leave that until for our demonstration, which we are going to do before we end the class today. So the frame processing, I will demonstrate that. Unicast MAC address. What is unicast? Unicast simply means one-to-one communication. So if I am sending message to you right now, I should know your MAC address. By the time I get your MAC address and I'm sending to you, that is one-to-one communication. But what if I don't have your MAC address? Something is going to happen. We are going to also demonstrate that. So, broadcast MAC address. I don't know your MAC address and I want to talk to you. What is going to happen? I will forward my message to everybody. So everybody on my network, when I want to reach everybody, I use a particular address. That is called FFF in 12 places. Look at it. Okay. FFFFF in 12 places. So if I'm sending a message to that FFF, by the time my switch sees that message, the switch knows that this is meant for everybody. I'm also going to demonstrate this. Okay? But you need to understand, we just need to talk about some of these things theoretically. So you need to understand, okay, we've talked about this. So I want to demonstrate all of these things. So we also have what is called a multicast MAC address. Please, can you mute yourself? Who is talking there? So we also have what is called a multicast MAC address. Multicast MAC address is to set off. Out of, let's say, 20 people now, I want to send message to just 10 people. I can use a multicast MAC address to send message to them. So you need to know the difference between unicast MAC address, broadcast MAC address, multicast MAC address. I am going to demonstrate the unicast and the broadcast MAC address. Okay, MAC address table, we're going to talk about it too. So let's just talk about these things now. So let me move to my packet tracer. Let me go to packet tracer. So please, if you have questions, you can start sending your questions before I set up this.
Don't send your question now. That one is for the class. So just let me finish my demonstration, then you can bring in your questions. I hope that is clear, guys.
Okay. Can we see my packet tracer?
Yes, we can.
Beautiful.
Yes, we can.
Yes, you can see. Yes.
Yes.
So for those that don't understand what a packet tracer is a tool. It's a simulator we use in the classroom to do what we will have done in the real world scenario. That's the tool given to us by Cisco to teach in the classroom. And you guys need to know how to use the packet tracer. So there is a class I taught some days ago. I taught them the basis of packet tracer, how to design a network's packet tracer. I dropped the video on the YouTube channel for them. So you can also check the YouTube channel on packet tracer. When we get there, I will still teach you guys on how to use packet tracer. So you just need to, I need to introduce you to what a packet tracer is. Like the real equipment in the real world, routers and switches and all of those. Our students don't have money to go and buy those things. So how can they practice? This tool will put the commands at your fingertips. It will put the technology in your hand. Everything we're going to teach you in the classroom, everything you can do in the real world, let me say 99% of what you can do in the real world, we have these tools to teach you. And that is a blessing to this generation. But when I was a student, there was nothing like packet tracer. There was nothing like packet tracer. The only simulator that was available then was expensive. I forgot the name of that simulator. But Cisco was they were just fantastic to go and just get something like this for the academy. And this is one tool that you need to have under your belt. So when we get to that bridge, we're going to cross it. I'm going to show you guys how to download it, as if you don't know already, and how to make use of it. Because we have a lot of labs that you're going to do that has based on packet tracer. That's where the real work is. All this long story we've been talking about since we started, that's not the real work. The real work is when we enter CCNA2, guys, and we start configuring. And when we're done with the particular topic, and I will offload like 3 labs on your head, before you come to another class, you must have finished those labs. That's where the real work is. And if you really want to be good at these things, you got to do all those labs and finish them. So let's fire on, guys.
Don't forget what we said. What is a network? What is a LAN? A LAN is a communication between 2 or more computers. So it therefore means if I want to build a local area network right now, I can start the journey with just 2 computers. If I have these 2 computers right now, I'll link these 2 computers together like this. Okay. I'll link these computers together directly like this. I have built a local area network. So these 2 computers can talk to themselves if I assign IP address to them. Now, don't forget something. Computers cannot talk to themselves without IP addresses. IP address is a layer 3 stuff, and I'm probably, if we have time, I will get there. I'll get to layer 3 today. If we don't have time, that will be in the next class. It's a layer 3 thing. So before 2 computers can talk to themselves, there must be IP addresses on those computers. Now, don't forget we talk about TCP/IP. The implementation of the IP part of the TCP/IP is when you put an IP address on a network device or host. So the moment I assign IP address to a device like this, either manually or automatically, I have activated IP, that protocol, internet protocol. So it has to be there before the 2 systems can communicate to themselves. What if I go further and say, I have more than 2 people that want to talk to themselves, so I have like 4 people that want to talk to themselves. How? More than that. That means I will need a network device to aggregate this connection. So I can now go to my switch, bring out a switch, yank off this cable that is here, remove this cable, and say, okay, now since you guys are plenty now, we need to bring a switch. Now the switch has multiple ports. Look at the ports on the switch. Multiple ports. And we can go to, let me see if I can launch the physical part of this thing. What's that? Logical. Okay, that's physical. I can't see that one here. I wanted to show you guys the logical, the physical ports on the switch. Okay, let me just leave that one. It's not working for me. I can go to Google and bring a switch out for you guys to see. So now if I drop a switch here, now this switch, it can be 8 ports. It means I can link 8 people. It can be 12 ports. I can link 12 people. It can be 24 ports. It can be 48 ports. I think the highest I've seen so far is 1024 or something like that. Just one switch. So since it's just a small LAN, I can just link these computers to the switch. How do I link the computer to the switch? Back to our physical layer. I come to my connection. Now, we have not talked about cables. We just mentioned copper cable, fiber. When you come to copper cable, we have different types of cable. We have crossover cable. We have straight through cable. We have rollover cable. And ideally, for a computer to be connected to a switch, we need to use a straight through cable. A straight through cable. For like devices is crossover cable. Unlike devices is straight through cable. So since these are unlike devices now, I need my straight through cable. I can just come here, pick my straight through. How do you know it's straight through? By the time you point your mouse at it, it will show you copper straight through under. I carry this cable, plug to my computer. There are plenty cards there, but the one I need is fast Ethernet card. Now back to what we said about Ethernet. See now, this card is showing me fast Ethernet. What does that mean? It simply means this computer will be operating at the rate of 100 megabit per second. So it's based on Ethernet technology, but another variation of Ethernet technology. So if I click this now, come to my switch. Even my switch is showing me fast internet. It simply means this network I'm building right now is a 100 megabit internet network. 100 megabit per second network. That is the bandwidth of my network locally. So I can plug off any of the ports, go to another computer, plug here, go to another computer. So now we have linked 4 computers to the switch. I want to explain something before I go further. So we have taken care of layer 1, we have connection. We have taken care of layer 2, we have a switch. What about layer 3? IP address is a layer 3 issue. And it must be on our computer before they can talk to themselves. So let's give these computers IP addresses. Now I know we have not discussed about IP address, so you may not know much about the IP address, but I'm going to talk about it. That's going to be week 3. So let's give these computers IP addresses from this network. Let's say their network is 200.100.0/24. Now you are going to understand this when we do IP addressing. So this is like the network name where the hall belong to. So I'm going to go to one of the computers here and give this computer 200.100.100.1. Go to another computer, give this guy 200.100.100.2. We'll keep some net mask. We're going to talk about all of these things. Go to another computer, 200.100.100.3. Some net mask. Go to another computer, say 200.100.100.4. Now, if you look at this IP address, you see that something is common to all these addresses. 200.100.100 is common. Why is that part of the address common? When we come to IP addresses, I'm going to talk about that. Okay, now I've taken care of layer 1 issue, taking care of layer 2 issue, taking care of part of layer 3, because a router is a layer 3 and we don't have a router. Do I really need a router? It depends. But what I'm doing right now, I don't need a router. So layer 2 address must be present on my device or devices, and layer 3 addresses too must be present, because the computer needs to know that I am sending to so person, and the person must have my layer 3 address, or I must have the person's layer 2 and layer 3 address. But I'm trying to drive a point home here. What is the point I'm driving home? I'm going to talk about these 2 other protocols. One of it is HAP, Address Resolution Protocol. Address Resolution Protocol. The other one is ICMP, Internet Control Message Protocol. Address Resolution Protocol and Internet Control Message Protocol. Why do I want to talk about these things? Because these things, especially the Address Resolution Protocol, it is needed for our computers or switch to get their job done. Let me demonstrate that to you. First thing first, let's go to our switch. Now, you have not learned how to configure switch. You are going to learn that next week. Let me get into this switch. This switch has something called a MAC address table. The switch has something called MAC address table. How do we access the MAC address table? We also show MAC address table. So if I enter my switch and check the MAC address table, do you know what I'm supposed to find in this MAC address table? I am supposed to find all the MAC addresses of all the computers that are connected to this switch, because that is how the switch rolls. If you are plugged on port 1, in this table, it will add your MAC address and say you are on port 1. If somebody is plugged on port 2, it will say this person is on port 2, like that, like that, like that. That is how the switch will know, oh, this is not doing what I want. I think I'm going to clear it. But what I'm trying to tell you is this. This is one of the challenges we have with Packet Tracer. If I have not sent any message I just plug this computer on my switch for the first time, this table will be empty. The switch wouldn't know where these computers are. Let me clear. Let me see if this command works here. Beautiful. This is what I'm supposed to have. This table is supposed to be empty. Why? These computers have not sent anything to themselves. So if you read the curriculum, the switch can only know your MAC address when you send something through that port. You know, so you are now you did that side. So that is when it will open the frame and check the source MAC address and they'll say, okay, now you did there. And where the message is going to. When the person replies back, it knows, okay, now you did there. So what the switch will be doing at that point in time is populating this MAC address table. And the reason why it's populating MAC address table is so that you will know that computer A is on port this, computer B is on port this, computer C is on port this. So when message is sent, you just look at this table, it's like a map. Oh, this person is in this also place. He knows where the message is. That's number one. Just a minute. So sorry, guys. This is one of the things we go through once in a while.